So hello students, welcome once again to our TEJAS series. See, as I said, this is really according to me, of course, it's an exceptionally good question. See, when I got this question as a doubt, how I approach. So first thing which I always do, whenever I get a question of series and I can't apply any formula, any result, anything directly, what I first do is I open the series. So I just open the denominator first, because numerator has two summation, one summation variable is I and another summation variable is R, but denominator has only one summation sign with one variable R. So I open the denominator first. So I will write my series is, so whatever we have in numerator, so I am not rewriting it, but if I open the denominator here, put R is equal to 0, what will we get? We will get 2025 C naught, which is 1, okay, and then 2025 raised to the power 2025, then minus, when you put R is equal to 1, you will get 2025 C1, and this will be 2024 raised to the power 2025 plus 2025 C2 2023 raised to the power 2025 minus, I am writing one more, 2025 C3 2022 raised to the power 2025 plus dot 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 till the last term, which will be 1 here. Okay, so till the last, which will be 1 or 0. Okay, of course, 2 minus 2000 minus 2000, which will be 0. So 0 has not to be included. So anyways, that will be the last term. Now when I analyze this, see, look at it carefully and remember your permutation and combination. Now you will think that this is a question of series where binomial coefficient are involved, seems to be a series of binomial. Why are we going to permutation and combination? Now here is the key. Permutation, combination, and think about the principle of inclusion and exclusion. Inclusion, exclusion principle. Now, if I explain you with the help of an example, if I say there are 6 balls to be put in 4 boxes such that no box go empty. 6 distinct balls to be put in 4 distinct boxes so that no box go empty. What will you do? You will say, okay, total number of ways are 4 raised to the power 6. See, you pick up one ball, you have 4 options in front of you. You put it in one box, any one of those 4 boxes. You pick up another ball. Again, you have 4 boxes. There is no restriction. So all possible ways are how many? For every ball, you have 4 choices. So 4 into 4 into 4, 4 is power 6. But we need the case here when no box is empty. So we included everything. Now we will exclude those cases when at least one box is empty. Of course, from total cases, if I exclude those cases when at least one box is empty, what are we left with? We are left with those cases only when no box is empty. That's what we need. Okay, so at least one box is empty. You write it as 4C1 because there are 4 boxes. Why 4C1? I am selecting one box out of 4 and then I will keep it aside. Now how many boxes are we left with? 3. How many choices every ball has now? All 6 balls have 3 choices each. 3 into 3 into 3, so you write it as 3 raised power 6. Now, why is it at least 3 boxes empty? Because, see, when I am like considering all possible cases again for 3 boxes, so it may happen that I put all my 6 balls in one box, 2 boxes will go empty, or I will divide those 6 balls in just 2 boxes, I may leave one more box empty. So it includes everything, so that's why I call it at least one box empty case. But as you all would be knowing, whenever you exclude such type of statement, at least one, you always exclude extra. Okay, so there comes the principle of inclusion, exclusion. So we included, we excluded. But during the process of exclusion, we excluded few extra cases. So we have to include those cases. So 4C2. 2 boxes empty cases, we have excluded so many extra times. So we have to include those cases. So when I keep 2 boxes empty, so this is the case for at least 2 boxes empty. Now we are left with 2 choices for each box, for each ball. So total choice are 2 raised power 6. Now again, include, exclude, include, exclude. 4C3, 1 raised power 6 plus 4C4 and 0. Why? when I remove all the 4 boxes, there is no choice of putting ball in any box. Okay, now look at here. 2025 C naught is nothing but 1. Okay, so you consider here now, I will write here. Now for me, I will consider 2025 distinct balls and 2025 distinct boxes. In how many ways you can put the ball in the boxes? No box is empty. So total ways minus at least 1 box empty, because no boxes left are 2024, plus 2 boxes empty case, minus 3 plus that's the inclusion exclusion. So this statement lead us to this case, boxes and no boxes empty. Now tell me, in how many ways we can do it? So 2025 balls, 2025 boxes, that means the number of ways are how many, bachcho? So number of ways are 2025 factorial, because you have to put one ball in each box. So it's a simple case. 2025 persons, 2025 chairs. In how many ways you can arrange? 2025 factorial. So the value of denominator is nothing but 2025 factorial. So now series is 2025 factorial. So that's the denominator here. Now let's come to the numerator. Bachcho, I believe you all would have understood it now. Okay. Now numerator has 2 variables r and I. 10 raised power 4 is a constant. You can take it out from both the summation sign. Now here I will what I will do, I will first let's see, let's do it. So 10 raised power 4 is of course common. Now if I open it with value of I here, okay, so if I put the value of I here, I will get it as I is equal to 0. Okay, so the series is R goes from 0 to 2024 minus 1 raised to the power R, and then this is 2024 CR, 2024 CR, and then it is 2024 minus R, 2024 minus R raised to the power 0, which is of course 1. Okay, plus R goes from 0 to 2024 minus 1 raised to the power R, 2024 CR, 2024 minus R raised to the power 1. Okay, so I am opening the summation for variable I. So put I equal to 0, you got a term, plus put I is equal to 1, you got a term, plus put I is equal to 2, you will get another term. So I am writing one more term, R is equal to 0 to 2024 minus 1 raised to the power R, 2024 CR, 2024 minus R whole squared, plus dot 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 dot. The last term will be when I is 2024. So the last term will be summation R goes from 0 to 2024 minus 1 raised to the power R, 2024 CR, 2024 minus R raised to the power 2024. That's it. Now again, look at the expression, the first one. The first one, and compare it with this one. Each and every expression is like this. The only difference is of power. When power is 0, and see, remember, in exclusion, inclusion, exclusion principle, the power represents number of balls which won't change as you write the series. As you open the series, this is power which is not changing because that is number of balls. Clear? Now look at this one. Number of balls is the power that won't change. Okay, that's fixed. This base is changing, CR, this is changing, this is changing. So what it means, 2024 boxes, 0 ball, no box empty, not possible, this is 0. 1 ball, How many boxes? 2024 boxes. You have only one ball. Of course, not possible that no box is empty. This is 0. 2 balls, power is 2, which is fixed. Okay, so according to the principle of inclusion and exclusion, that goes towards the case when there are 2024 distinct boxes and 2 distinct balls, no box go empty, not possible, 0. The only case before this one, everything will be 0. Why? Because now here is the case when you have 2024 balls and 2024 boxes. So again, no box go empty. The answer will be 10 raised to the power 4 we already had. 2024 factorial upon 2025 factorial. So just solve it and we have the answer. 100 into 100 upon 2025. 25, 81, 25, 4. So 400 by 81 is the answer. So answer, of course, for me is not important. The series is really an important one. The way we connected it with inclusion exclusion principle of permutation and combination. So now keep that thing in your mind, that expansion, that inclusion exclusion principle expression, how it looks like. Okay, so you set a figure of like balls and boxes and then you set this expression in your mind so that you can compare it. See, that's how I could compare it. When I was thinking about it, from where will I get it, all of a sudden I came like that idea came to my mind that yes, it seems to be an exclusion inclusion principle series, and we got the answer. Okay, so that was the second question of the day, bachcho.